I'm going to talk to you today about hitting the limits of Windows Azure storage, and that's really limits around the tooling that exists at the moment that we've had to overcome delivering projects and products for some of our clients. So I wanted to share that with you today because it's quite an interesting problem to solve. Won't be showing you any code or technical, it's more of how would you solve this problem using the existing tooling, and when and where to build out and write your own tooling where you need to. Okay, so quick intro about myself. So Amido is we're a technical cloud consultancy. We're based down in Brighton. We've also got offices in London. We offer strategic architecture. Crucially, we build and deliver in the cloud space, and we also offer partnerships. So we get quite a lot of our work with partnering up with digital agencies who don't have technical capacity, but we also contract directly to our clients as well. That works well for us. A bit about myself. I'm co-founder and MD. My day job, platform architect by trade, things that kind of excite me. I'm really into service delivery, DevOps, so how do we get cloud out into production? How do we protect production from risk, from instability? How do we monitor the software that we write once it gets out into production? It's a sort of brave new world. Once we're into Azure and cloud, it's much harder to do. And the tooling on offer is limited and quite immature. But obviously it's changing and there's new releases every day. So it's a challenge to work out what to write and work out what to buy off the shelf. One of our philosophies is to write as little amount of code as possible. If we can deliver for our client without writing any code, we've won. But and obviously we can pass those savings on to our clients. But because of where we are, well, we always end up writing code. But it's quite an interesting place to be. Right. Okay. So I'll try. I did have half an hour. I think we're all right. It's 10:10, so I'll speed up a little bit and make some time back. So what's going to be in this sort of presentation? So I'm just going to set the scene about this particular. What I'm presenting is a particular problem that we've had to solve for a particular client. I'll define the problem, get you to think about it a little bit, and then I'll talk about the solution that we used. Okay, so the domain of this particular problem. So we were approached by an agency to help them solve a problem for their client. The problem was how to manage and distribute and share images on a sort of massive scale. So the actual domain is it's a domain-specific cloud platform for medical images. So coin the term MIP, which could be medical image platform or massive imaging platform, what you like. And basically the problem we have to solve is we need to get images into the cloud. We need to then be able to display those images using some kind of front end. We need to be able to manage the whole estate. We need some systems management to aid the actual management of that capacity. And what I'm focusing on today is scale. So this kind of like nuclear button here is how do we scale this problem when we're dealing with sort of massive amounts of data. And it's all focused around sort of medical industry, but it kind of applies to anything in the image space where you're dealing with vast amount of data. Okay. So let's talk a little bit about the actual data. So we're talking about massive amounts of storage, exponential growth in the medical field. If you're kind of interested in this, go out and have a look at TED. You know TED. There's some really, really interesting talks at the moment in the field of medicine. There's some really groundbreaking stuff being done. The hardware that the medical industry is using is just creating massive amounts of data. Data points, images, scans, and it all has to be usable, for the medical industry. So we're talking about exponential growth. Probably from about 5 years ago, this exponential growth really started. We're talking about medical images, so there's an indefinite amount of storage, and of all of those images captured, they need to be retrievable in a fairly speedy manner, so we can't really off-site these images into some more traditional sort of archive backup. They just need to be available. So if we talk about an MRI scan as a fine example, so a typical MRI scan's about 500 meg of data, give or take. That's images and data points as well. And in the US alone, there's 30 million scans a year. So that's a serious amount of data that we've got to somehow make sense of. So let's look at the numbers. So we've got half a gig per scan, 30 million scans a year. Remember, 1 million gigs is a petabyte. So 1 year of scans is roughly about 15 petabytes of data. 15 petabytes is 15,000 terabytes. One Azure storage account at the moment has a limit, a ceiling of 100 terabytes. And that 100 terabyte limit includes blob storage, queues, and table storage. So roughly, give or take, in 1 year, we're talking about 150 storage accounts to manage in some shape or form. So that's kind of the size of the problem we're facing, and like I say, the challenge has really been around how to manage this data using the existing tooling. So I'm not really going to focus on the product. That's not really why I'm here. It's just to talk about the scale and how do you manage that data. Okay, so this data problem, it's a management headache from the systems management, from the ops perspective. You've got a bucket of data. I like to think of a storage account as a bucket in this sense. Data goes in, bucket fills up. When the bucket's full, you move on to the next bucket. So we've got a lot of buckets, basically. That's give or take 150. So you can kind of see, and remember, this is just for 1 year, and it's growing exponentially all the time. So, as we speak, that's probably redundant. It's now 151 that we need, So it's going a bit crazy. And obviously, as the medical hardware, the quality of the medical hardware improves, the more data each scan will create as well. So as well as more scans, more data. Okay, so this problem. So to kind of put the problem to you, to get you thinking about how you might do it. So how do we manage the distribution, replication, and scale of petabytes of storage with very little tooling? It's almost without any. That's not quite true. It felt like it at the beginning. There is a bit of tooling to help you, but essentially, with very little tooling, how do you solve the problem? Okay, so the first part of that problem is solved for you. So distribution and replication. So when you sign up for a storage account, you get geo-replication included in the price. You can actually turn it off, but I can't think of any business case where you might want to do that at the moment. So when you sign up for a storage account, you have to assign it to a data center. So your storage account lives in the data center. You can assign that to an affinity group within the data center, but ultimately you're saying this storage account lives in this data center. And there are data centers are grouped in pairs. You have a primary location and a secondary location. So we've got, so this is one pair. We've got Southeast Asia. We've got North Europe and East Europe. We've got North US and South US. We've got East and West. Yeah. So those are the data center pairs. So for the purpose of this demo, I've put some data into North Europe, and that's the primary, because that's what I specified. The secondary for that is in Amsterdam. So whenever you do any CRUD action on table storage, the transaction level at the table, under the covers, your data will be triply replicated within that data center, so across 3 fault domains and 3 primary domains before the call returns. And then asynchronously in the background, that data is then geo-replicated to the secondary data center. So when I make a save to my storage account in Ireland, by the time I get the call back, it would have been triply replicated. Well, it would have been saved to one store and then replicated twice, so triple replication. And then asynchronously in the background, that data is going to be written out to Amsterdam as well. And that's the true with all of the pairs around the data center distribution. So that first problem, really, you get out of the box. Distribution and replication. You can't currently, as a consumer of Azure, you can't currently hot swap your primary and secondary locations. But if one data center went down, you'd contact Microsoft and they'd do some magic in the background with their operations tooling and swap you to the secondary location. So the data's there. At the moment, you don't have, as a consumer, the option to actually do the swap yourself, but it can be done. So you get that for free with the money you're already paying, which is fantastic. So that's the first part of the problem. So the second part of the problem is scale. So the challenge here is the management of data. It's a cloud-based platform, so we've got multi-tenancy. And we're trying to solve this management of storage account, these 150 storage accounts, which is just going to increase. Some kind of sharding policy. It's only 100 terabytes of data in one storage account, which fills up pretty quickly, relatively. And so we've got this idea of somehow these buckets are filling up. So we need to manage the data across the buckets. We need to then provision more buckets. We don't just want to go live with this product with 3,000 storage accounts. It's just not practical. So we start off with a number of storage accounts when the product goes live, and then we add storage accounts at at the right time, and that right time is kind of decided by the tooling. We get feedback, we understand the shape of the platform, how quickly data is being added, we do capacity planning, and then we talk to Microsoft and say, look, we need 10 more storage accounts, we're going to plug them in. When you sign up for a hosted service, by the way, you get a kind of artificial ceiling of 5 storage accounts, which you can get lifted by raising a support ticket. So if you're in the management studio, you try to create more than 5, it will basically say your quota's been reached. So sharding and scale, so let's just kind of picture this. So if you imagine, so purpose of this slide, we've got 4 empty buckets that we start off with when we go live, so that's 400 terabytes of potential storage. They start to fill up, so we've got some kind of sharding policy. So the first insert might go to bucket 3, the next insert might go to bucket 1. So these buckets are roughly going to fill up at the same rate. We've got 4 active buckets at the moment. So as these guys start to fill up, through the tooling that we've created, we're going to get some kind of warning, some kind of alerting to say your buckets are filling up, you need to do something about it. So we speak to Microsoft and we get 3 more buckets provisioned, they're empty. These guys are still active, things are still going into these. These guys are now available as well. So we've now got 7 active buckets. These guys roughly fill up at the same rate because of the sharding, and also data starting to go in these. So when these guys are full, they just become read-only because obviously the data in them is still required by the platform, but we can't put any more data into them. So these guys become read-only, and any further data goes into these. Obviously in this case we've got 3, so they'll fill up faster than that, but you get the idea. And then over time, images in some of these buckets is going to get archived or going to get deleted for whatever reason. So some of these buckets that were read-only, the threshold will drop and they'll become writable again. So we've got this problem of turning off the tap, if you like, and turning the tap back on and provisioning new storage. Okay, so what tooling can we use? So we've got the Azure Management Portal, we've got the Silverlight portal that you've probably all seen, and we've got the HTML5 portal now, which is, I think it's still in preview. Is it still in preview, I think? Yeah, it's still in preview, but new features are being added all the time. You can't yet use the portal to actually see into your storage, so you can't see the data that's in them, but you can manage the actual storage accounts, so you can provision new storage accounts, basically. You've got Cloud Storage Studio, Cerebrata, Redgate, which will become your best friend, no doubt, for kind of manipulating data, and it also gives you access to hosted services and all sorts. And now I'm just going to have to do a swap to my other laptop because I just want to show you a little bit of Cloud Storage Studio, but the demo gods are against me. I've brought my Mac and it's not showing so nicely on here. So this is bigger. Let you guys see it at the back, and I'll just do a swap halfway through. And then we've got this kind of gap where stuff is being created all the time. And then you have to make a choice at some point whether you're going to wait for new features to be written or whether you're going to write your own. So it's this bespoke part that I want to show you. So the architecture of the system, just to give you an idea of what's going on. So images are constantly coming into the system and less frequently going out of the system through archiving, but it's really all about the in. It's all about the coming in. So we're using Azure Service Bus in the actual architecture. This idea of understanding how much storage we've got in a bucket, setting thresholds of a bucket for the systems management perspective. So given that we can't really control the rate of data coming in, that we need to set some threshold. So when a bucket is maybe 90% full, that's a good time to start worrying about it. Maybe when it's 75% full, that's the time to start provisioning new data. So we need to be constantly monitoring the amount of data in a storage account, but also for the purposes of this, we don't need to be that accurate. It's probably okay to say there's 900 terabytes rather than 903.271. Obviously for billing and that kind of thing and metering, that side you want to be a little bit more accurate, but for the purpose of provisioning and scaling, we don't need to be that accurate. So we have a topic called new image. So when a new image comes into the system, we want to do a couple of things. One might be to notify a website that a new image has arrived. And then there's some other things we want to do, some other business logic we want to drive off that topic. And then this is the one we're interested in here, which is to calculate storage. So every image comes in, we go off and we then calculate the amount of storage against the bucket that image and its associated data has come in. So a new image in this example here is not necessarily just one image. It may be a collection of images. So the original, we want the screen res image. We probably want the thumbnail as well. And there's a lot of metadata associated with all the data points that come in with it. So that's kind of wrapped up by this new image topic. And we have to calculate the storage for all of that. And I'll show you how we do that. Okay, so there is no tooling at the moment to calculate the amount of storage currently used in a bucket. So, but what has been given to us, if you like, is a blog. It's quite old now, but it's still very relevant. I'm just going to click through to it. I'll put this deck up on SlideShare, by the way, so you can grab it. So I'm obviously not going to go through this in detail, but basically in here is defined. Sorry, try and use this mouse if I can. There are a number of algorithms about how you calculate storage. So we've basically had to take these algorithms and write the code for it. Sorry, it's not actually that clear, but you can imagine so you've obviously got the obvious things like the size of the file, but obviously the length of the file name makes a difference. The length of the keys you use, so we're using blobs containers, so the length of that key in the blob container takes up storage. So you have to take into account all of these things. So we basically wrap that algorithm in a service to help us calculate as we go on. Okay. So what do? So we expose that data as a feed. One of the bits of functionality we need to do with this data is to calculate storage to scale. There's other requirements, as I said, around billing. So what we do, we have a worker role, essentially, that's watching the subscription. When every time a new message comes in, we recalculate storage. We then store that information in table storage. And then we have a simple website, which we've actually hosted in Azure Websites. It's free. It's pretty lightweight. Why not put it up there? And that exposes on a per bucket level, on a per affinity group level, and then on a total level, the amount of storage we've got. And once we've got this information, we can start consuming this feeds from other systems. So guys probably can't see this at the back, but just a schema we've come up with for metrics. So we've got our instance. So these are our bucket names. So we've got MIP. NEU is our affinity group name, Northeast Europe. Bucket 1, bucket 2, bucket 3, bucket 4. And obviously, as we scale out and add buckets, that list will grow. And then this is a percentage used. So currently in bucket 1, we've got it's 32%. So that percentage is based on the knowledge that a bucket currently holds 100 terabytes. So 32% in bucket 1 is used. 31% in bucket 2 is used. So they're kind of growing at roughly the same rate. Overall, for that total affinity, we've only got one affinity group in this example, which is Northeast Europe. So the total percentage used for that affinity group against what's currently provisioned is 31%, and the total storage, 31%. Okay, so we can kind of use this information and drive it out. So this whole problem is really around monitoring and being able to react off certain events that are changing all the time. So the buckets are filling up, the buckets are emptying. We need to provision new storage. So here's our topic, our subscription. We've got a worker role that's hooked up to the subscription. That worker role is taking but basically what we do, we pass in the path to blob storage in that message, and then the worker role goes to blob storage using the algorithm, calculates the amount of storage used, writes that information out to table storage. Then we have a web role, which is basically a Azure website on the left-hand side there, that's using that table storage to publish a feed. That feed is then available for anybody who wants it, any of our systems that need it. This particular example, we have a worker role that regularly reads that feed, and using that information, depending on what kind of alerts we've set up, we'll either send an email to the ops team or we'll take action to turn the tap on and off. So we have configuration tables in table storage that lists all of the accounts and then whether those accounts are active, so whether the accounts are readable or writable. And then when data comes in, that information is used. So a new image arrives. Which buckets can I put the data in? We've got quite a simple sharding policy, kind of round robin. It doesn't need to be any more complicated than that. Okay, I can use bucket 1, put the data in bucket 1. Next time it comes in, bucket 1's full. Okay, I'll have to put it in bucket 4. It just goes around like that. It fills up quite gradually. So that's it really, just this problem of turning a bucket on and off. I just wanted to quickly show you Cloud Storage Studio so you can kind of picture it a little bit more. Just bear with me. Okay, so this is our subscription. This is our staging for the purpose of this demo. We've currently got one hosted service deployed. We've got a number of storage accounts. So we've got bucket 1. Our buckets that we use for data don't have anything other than data in them. So while in a storage account you could add table storage or queues, for our data buckets we only put data in them, and then we have different storage accounts for things like system configuration. So this particular bucket, 21 containers. Each container represents a user of the system, if you like. And then within that user, so this particular user has, can I tell, quite a lot of images in there, okay? And if I scroll down, you'll see bucket 2 here. So it's actually the same user. So you can see they've been sharded across here. So OCBFA. OCBFA, if I look in this guy, if I've still got internet connection. Here we go. So if we take a look at this storage. So you can see the original image has come in, it was 2 meg. We've extracted now, and if you can imagine, this is kind of replicated for each piece of data that comes in. The data quickly grows up. The data quickly increases, and these storage accounts are filling up fairly quickly. So when we're calculating the metrics, rather than storage for a particular image coming in, we're having to take into account, using that algorithm that we got from the blog, we're having to take into account the actual length of the name, and obviously the data that's in it. The GUID takes up a certain amount of storage, and the actual blob container takes up a certain amount of storage. So we've got all this data coming in all the time and data going out. And then as we need more storage accounts, we'll provision them using the Azure Management Portal. Oh, I've lost it. Right, cheers. So this is the feed, basically. I just wanted to show you quickly. So we've just got it up there. It's just a normal XML feed that anyone can hook into, and obviously there'd be security around this. Don't want anyone connecting to it. And what else? Yeah, that's it really. I think that kind of concludes the story. So it's been quite a challenge, obviously, because when we were making decisions what to do, we knew that Microsoft have got, they're obviously constantly building out the technology and the tooling. There's new generations of actual storage coming out, the actual physical clusters, which offer different capability. The next version of the SDK, no doubt, will have some of the features that we had to build ourselves. So it's a question of deadlines versus how much we want to write. Obviously every line of code you write becomes a potential maintenance headache. You have to maintain it anyway, so it has a cost. So we had to make a choice. And like all good solutions, we think it's pretty simple, because ultimately it didn't have to be any more advanced than that. Where is my mouse gone? So let's just go back to here quickly. So what publishing the feed gives us obviously the ability is then for things like billing to plug into that. And we at the moment we're only exposing the amount of storage that is used by a bucket. When billing comes in, we'll start exposing the amount of storage used by a customer, and obviously then the granularity of that information will be much more valuable. And this worker role, we can build out tasks and actions as we see here, but it's essentially, as we begin to understand the system, these email alerts will become automated tasks. So at the moment, there's some things that are still manual because we don't fully understand the system in terms of how it performs. So it needs a person to understand, and then we'll drive out patterns from that. And those emails will become automated patterns, such as turning the tap on and off. That concludes it really. So as Planky talks about, this is the next step slide. So you can get cracking with table storage straight away. Cloud Storage Studio. You've got the Azure Management Portal to get up and running. You've got table storage in there. You've got queues. You've got blob storage. And incidentally, it's basically queues and table storage are just abstractions of blob storage. So you've got this big blob container. That concludes the talk. So, thank you.